lesson 8.3. And starting with the warm-up, let's see who simplified this complex fraction correctly. All right, so we did these yesterday. So the strategy is you got to first make the numerator one fraction. Right now it's not a single fraction. And same with the denominator. So what I kind of showed you was I like to kind of just do this. Ooh. There we go. I kind of like to just off to the side first get my numerator to one fraction. So I kind of just like picture the problem like this. All right, first I just want to add these together. Now this one, you could have factored this denominator. We could have factored out an x.
Nope, that's too difficult.
Okay.
Yeah.
Which gives you an LCD
X plus 1.
of x times x plus 1. Okay? You should always do that. You should always factor the denominator because that could help you determine the LCD. So actually, the only fraction we need to change is the second one. This already has the LCD.
How did I mess that up? Wait, no.
This one, I just need to times the top and bottom by x plus 1.
I just didn't factor it. You still get the same
So you kept it as x squared plus x?
Yeah.
Yes, but when we go to simplify, you'll have to factor. Let's just hang tight. We'll see if you still got it. All right, so then up top here, I get 3x plus 3. Don't forget to distribute. Add those together. You should have got your numerator to be 3x plus 5.
Yeah, I got that.
Okay. And if you have the bottom as x squared plus x, that's okay for now.
Wait, 3x.
3x plus 5. Bless you.
Plus. Well, thank you. You just told me to go plus.
All right, now I need to do the same thing with the denominator. So I kind of just do this. And again, if you kind of want to do that, you can. So my denominator currently has the addition problem of 3 over x squared plus 1/5. So my LCD for this one would be 5x squared. So this first fraction, just times the top and bottom by 5. Second one, times the top and bottom by x squared. Okay, everybody with me? So I get 15 over 5x squared plus x squared over 5x squared. Now it's probably easier to make the common denominators. Now we're ready to add.
What did that one write?
So I would write the top as x squared plus 15 over common denominator 5x squared. Okay, that's the first step. Make the numerator and denominator a single fraction. Then I'm just going to replace this numerator with that 3x plus 5 with that single fraction over x times x plus 1. And the denominator with x squared plus 15 over 5x squared. And now it's just a division problem. Right? You don't have to write this down, but this says the same as this. The numerator is being divided by the denominator. But if you jumped right to keep, change, flip, that's fine. So when I say keep, change, flip, that means I'm just changing the multiplication problem to a division problem, where I keep the numerator, change the division to multiplication, and flip my divisor. Okay, so Wesley, here is the part where I was saying you would want to have this factored, but if you didn't, you could factor in this step. But when we multiply fractions, we kind of factor them first, and then we get to cancel out, because what actually cancels out here? There's one thing they have common in the numerator and denominator. just not these x squareds, because that's separated by addition, but this one has a factor of x, and this one has a factor of x. Yep. So if you want to, like, you could put parentheses around, like, okay, like that's a factor, this is a factor, if that helps you see the factors. So my final answer here would be 5x times that, and again, you don't have to distribute it through. Did you guys figure out, does the textbook distribute through?
No.
No. Did the worksheet?
No.
Okay, good.
Wait, no, I don't remember the worksheet.
There's no textbook, is it?
That Alex is on it?
Oh, sorry, Alex, yeah.
No, I didn't distribute.
It didn't distribute? Okay, good. Did anybody get that?
Yeah, that's what I got.
Yeah, I got it right now.
After you did it.
That was close.
Okay, that's why I picked one of these. These are hard. Lots of steps. Now we're all warmed up, huh?
No.
No.
Yep. It takes a while for me to warm up.
Oh,
Do they have to graph these things?
You get to, yeah.
Why?
That's what we're doing right now.
You guys, it's not bad. All right, I want you guys to do a little exploring. Complete this table and plot the points and see if you can guess what the graph looks like. Don't flip over your paper. Don't.
Interruption. We are now out of our.
Yeah, that was
Everybody
quick.
hold
Quick as
on.
hell better.
How do you graph something that is divided by
Alyssa didn't follow direction. Good question. That's what we're going to talk about.
What do you do that?
I don't want to tell you the answer yet.
Ah.
Maybe talk about it with somebody else.
Connor, I'm gonna flip the page.
Me too.
Don't do it.
You can't do this one. You can't do 0.
Ooh.
This makes no sense.
I'd say it's 0, 0.
You can't do
It's
that.
two different graphs. Huh? I didn't look. Is it?
Maybe.
I
I'm
didn't.
flipping the page.
I didn't put it there.
I'm not flipping the page. I'm valid.
It's unique. I really don't know how to work correctly.
Don't look at my paper, Will.
I flipped the page.
Oh, Willis.
Yeah, I flipped the page.
Oh, that
Connor,
makes sense.
you cheater.
I'm not cheating, I'm learning.
The inverse should be the same thing. This makes no sense. Like the inverse function.
Hyperbola. I'm a hyperbola.
Huh? How did they get those?
Oh, I've seen these before.
We know.
Same.
What?
All right.
Okay, can you send Connor to the principal's office? He's making death threats.
I am not making death threats.
I have to take that stuff seriously if you say that, Willis. I'm not kidding. I know a teacher at my old school who literally got fired because she didn't report something. So don't joke about that. That's what I'm saying. Okay. So here's what you noticed. We can't divide by 0, right? Ooh. So there's something going on there. We'll talk about it. All right. And then when you plugged in all these positive ones. Okay, so you got these really tiny values. So I got -3, -1/3, -2, -1/2, -1, -1. What if I were to plug in -1/2? What if,
-1.
what if I were to plug in this? What's this? Times my reciprocal.
-2.
Thank you. -2.
Got it.
Weird, right?
Weird.
Okay. Then I have 1, 1, 2, 1/2, 3, 1/3. What if I were to plug in a positive 1/2?
2.
2.
It does not touch the y-axis.
Okay, so what ends up happening here, first of all, let's connect our dots left to right. Justin said this correctly. There's kind of two separate graphs because I cannot plug in 0. So I can't connect these dots because x cannot be 0. So what ends up happening, we can plug in numbers really, really, really close to 0. Somebody do a really small number. Do like 1 divided by 0.001.
Yeah.
Or you can do it.
1 divided by 0.001. What do you get, Michael?
1.
There.
That's a
Sure.
big number.
You want a really big number.
It's like a billion or something.
Yeah, it's a really big number, right? So if I plug something in really small, I get something really, 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 really big.
Do you ever get 0?
Could we ever plug in 0 here?
No.
No. So it gets really close to 0, but it doesn't touch 0. Okay, similarly over here, if we pick just some negative x values just to the left of 0, like negative 0.001, we get really, really, really big negative numbers. So it kind of looks like that. And then Nick also said it never touches the x-axis either, because can you guys think about x value that I could plug in and get out 0?
No.
No, there's no number that I could plug in for x that would give me out a 0. So this actually just kind of ends up hugging up next to this axis too. And this is what this graph looks like. That's what was on the next page that I didn't want you to look at. So the shape of this graph is called a hyperbola. Don't say hyperbola. It's pronounced hyperbola. Hyperbola. And it basically just has like these two symmetric branches. All right. This is my parent function. Just my plain 1 over x function. Okay, it looks like this. You guys just graphed this. And it approaches the x and y axis. So we have these things called asymptotes. Have you guys heard of asymptotes before?
No.
Okay, great. This is perfect.
That's
This is new for us. Asymptotes in math, there's like 3 different kinds, and you'll learn about them in pre-calc, but for now you only need to know 2 kinds. We can have something called a vertical asymptote or a horizontal asymptote, and that just tells you what direction it's going. So if it obviously is going up and down like this, it's called a vertical asymptote. So this graph actually has, now I just draw this in dashed, a vertical asymptote. And basically what that is it's something that your function gets really, really close to but doesn't touch. Can't touch that asymptote. Did you get my joke?
Yes.
Thank you. All right. That's a vertical asymptote. I often use
I
VA.
didn't hear it.
Let's not say it.
Scary.
I thought it was funny.
Come on.
It is funny, but
It's not funny if you have to explain it. Yeah. All right. And then if we have one going this way, horizontally, if our graph gets really, really close but doesn't touch, and in this case we just talked about how it's never going to reach 0, that's called a horizontal asymptote. Okay. Vertical asymptotes in short is where your function's like undefined. Okay, now there can be different types of discontinuity, like you'll learn about all that if you ever take calculus. But for now, what you need to know is like vertical asymptotes would be where we're undefined, like x can't be 0 in this case. So we have a vertical asymptote there. All right, I'm gonna pull up my good friend Desmos, and we're gonna kind of look at some transformations here. But you guys already know a lot about transformations. So this will, again, be applied with our shifts, our reflections, all that good stuff. Just with a new family of functions.
it just goes down halfway when I sit on it.
Wesley, can you please pay attention, Wesley?
They just call me
We're not
fat.
learning anything. You're distracting me from watching
They just
this.
call me fat.
You
All right,
want
so here's
watching?
my parent function. Ready?
Oh,
There's what you guys just graphed.
cool.
Okay, it's just graphing the reciprocal of all the numbers.
You should zoom out a lot and see if it ever touches.
Okay.
Never touch it.
It's touching. Are you sure?
It's definitely touching.
No, it's not. Okay,
I think it is.
the reciprocal of 1 is 1. The reciprocal of 2 is 1/2. Reciprocal of 3 is 1/3, vice versa. Reciprocal of 1/3 is 3. Okay?
Whoa.
All right. So you have this in your notes. Is it A over X minus H?
Yeah.
Is
Yeah.
that the letters you use? Okay.
Yep.
Oh.
Whoa.
Shoot, I'm giving it away. Okay. So we know normally that when I add or subtract a number kind of like outside, so see how this one's not being added or subtracted to my x, it's kind of being added or subtracted outside of the fraction.
Uh-huh.
What does that usually do?
It moves it
Which way?
up or down.
Up or down. That's a vertical translation. That's what they're telling you right here. Okay, so if we look at decimals, here's my k value. If I change that, it just shifts it up or down.
That's so cool.
Can you do that again?
Do it again.
Please.
Oh.
Yeah, look at it go.
But it touches the x-axis.
No, it does not.
Well, okay, good question. So it's still not touching my y-axis, right?
Yeah.
But now I'm adding or subtracting a number out here, so that's going to affect now where my horizontal asymptote is. Okay. Did you say y?
No, you said
Oh, okay. We'll look at some examples. All right. We've also talked about if I add or subtract a number just to the x, or kind of like inside the fraction, what does that do?
Left or right?
Left or right? Yep. Horizontal translation. Let's look at that.
Then that changes the vertical asymptote.
Exactly. Now that changes my vertical asymptote. Let's say h is 5.
5.
So I have x minus 5. So what can x not be?
5.
There's your vertical asymptote.
It's so easy.
Yeah, it's not bad.
You do it again. Carter was talking to me.
You were watching.
All right. The
I was
only
trying to
other
listen to
thing,
you right in
folks,
my ear.
a this
Yup.
number up here, if it's not 1, that's just gonna stretch or shrink. What if it's negative?
The opposite way.
It
What do you
will
call that in math? What transformation?
shrink.
Reflection. Good job, Justin. Reflection.
Whoa! Wait, what?
Do it again.
Do it again.
Whoa.
If that number is really big, it
One more time.
vertically stretches it.
Should you like max out all of them?
Whoa.
That's our
Whoa.
life. Yep.
Whoa.
Whoa.
Whoa. Bunch of YouTube
Whoa.
videos.
Here's
Now
our
reflective.
hyperbola.
Now reflective.
Now do it the other way.
Okay, now reflected. Here's what easily used.
Whoa.
It's the same thing.
Whoa.
They like touch. Wait, what? Oh.
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 Oh. Wait, what?
What?
Let's go.
What if a is 0? This drops out. I'm just left in the horizontal line. Whatever
yeah,
k is.
yeah,
Y equals K.
Sheesh. Okay.
Not cool.
Willis, you play with cow feet all day.
Yeah.
Oh.
Bobby.
They're roasting me. What are you gonna do about it?
Oh, what are you gonna do about it?
Okay. So this is kind of like our standard form for these ones that we're.
That's why.
This is kind of like the standard form of the ones we're gonna graph today. Here's your steps for graphing. The first thing you're gonna do is you're gonna find where your vertical asymptote is.
How do you spell it?
Yeah, I'll do it.
Oh, it's here.
Asymptote. I often just do VA. Vertical asymptote. So how you do that, my friends, how you do that is you got to figure out where your function's undefined. So you set your denominator equal to 0.
Like we did with the other ones.
Kind of, yeah. Yep. Let's find our key point. So I'm going to take that x minus h.
And solve for x.
Yep. I'm going to set it equal to 0. So I get x equals h. Now, because the vertical asymptote is technically like a vertical line, you need to keep x equals in front of it. It's like an equation of a line. Okay? Sometimes people will tell me, oh, vertical asymptote equals 5, and I take points off. They'll say this.
X equals 5.
It's technically that is your asymptote, is that dashed line. Okay? And I will have you draw that in on your graphs once we actually graph these. All right, that's the first thing you're going to do is find the vertical asymptote. The second thing you're going to do is find the horizontal asymptote. And we noticed off that Desmos graph, so I have to use HA, the only time our horizontal asymptote changed was when? Do you guys remember?
Negative.
Not when it got reflected.
Oh, wait. Horizontal is this way?
Yep.
Oh, so if there's something outside, if K changes.
If it shifts up or down. Good. Yep, if K changes. Good job, Willis. If it shifts up or down. So for these ones that we're graphing today, and this rule is gonna change once we do harder ones, but for now, in this form, it's just going to be at y equals if there's a k value. If there's a shift up, it's now at y equals 2. If there's a shift down 4, it's now at y equals negative k. Negative 4. All right, and then the last thing you do is you just plot points. You can say helper points if you want. Around the vertical asymptote. Because that's where all the action happens, around the asymptotes. So if the asymptote shifts over 10 units, you don't want to pick points around the origin, you want to pick points around 10.
Why the vertical one, not the horizontal one?
Because that's how we decide like what x values we plug in. We don't plug in y values. Good question.
True.
All right, we're only going to graph 2 of these, and that's it.
Sweet.
How long's his homework assignment?
I actually think it's only, I think it's only 8 problems.
Is it a worksheet? Is there 2
With
of them?
20
Book assignment.
each. 23 parts. I'm sorry.
What did you say?
Do you think I can finish this
Is
one?
there a book and a worksheet?
Just one. Just one.
Oh,
Hey, do you think I can finish this one?
What kind of truck is that?
We got a new one today. We
What?
got some steel on it.
All right, pay attention to me.
What?
I've been constantly fighting for your guys'
Greenhouse?
attention. All right.
Wesley,
What?
We got a graph each function. We will state the domain and range after we get our graphs done. But these are the steps I want you to do. First, we're going to find the vertical asymptote.
3. X equals 3.
Okay. Yep. Take the denominator. Set it equal to 0.
Do you have to draw that in?
Yes. Good question. We do want to draw these in dashed lines. So you're going to come over to 3 on your x-axis. This is a vertical asymptote. You don't have to label it on your graph, but I do want to see these asymptotes. When you hand in your homework assignment, I should see the asymptotes on your graphs.
Okay.
Okay. All right. Second, we're going to find the horizontal asymptote. And for now, that's only going to occur if we have a shift up or down. And it looks like I have a shift up 1. So my horizontal asymptote's now going to be here.
So it can't touch that.
Right.
Do you have food?
Me? No.
Do you have chicken and rice?
No.
I do. Well, not chicken, but rice.
Chicken fried.
Okay. You need at least 2 points around your asymptote. So 2 to the left, 2 to the right. I sometimes do 3, but you need at least 2. So my asymptote's here at 3. So I'd start by doing like 0, 1, and 2.
0.
You can put 3 in your table if you want and kind of just put like a dash through there knowing like that's where your asymptote is to help yourself remember like, oh yeah, we picked 3 to the left, 3 to the right. You have to have at least 2, okay? All right, now from here we just plug these in. Now a lot of this we can do in our head, folks.
True.
0 minus 3 is negative 3, so I have negative 2/3 plus 1. 1/3, yep. So 0, 1/3. Just barely above.
Got it.
Okay, let's plug in 1. 1 minus 3 is negative 2. 2 divided by negative 2 is negative 1. Plus 1, 0.
0. Wait.
Wait, what?
Oh my gosh. Okay, here we go.
Alright.
No, we mean like 0. Weird. Before we said not 0.
Well, we have some shifts going on here now.
Negative
shift.
1.
Okay.
2 divided by negative 1
Oh,
is
yeah, you're
negative 2. Negative 1.
2 is negative 1. Yep.
Good job, Willie.
Thank you.
Yeah, so guys, just because, because here we can plug in 0 now.
Huh?
Here we can plug in 0 because we have some
because
shifts.
it's not the VA.
Right. All right, I'm going to give you these ones. 3, 2, 1 and 2/3
1 and 2/3.
is what you get for those. You'll get plenty of practice, don't worry. 4, I'm at 3.
Oh crap! What did I do? 3, 2, 1 and 2/3.
All right, so if you do this correctly, if your asymptote's in the right spot, and you pick points around your asymptotes, the points should be somewhere near the asymptotes. So see how they're kind of like hugged up towards the asymptote, kind of?
Yes.
Yeah.
Okay, that is what your graph should look like. So then all you do is you connect your dots and approach the asymptotes.
Without crossing.
Without crossing, yep. Really close to, but don't touch.
Got it.
Exasperating.
Like that. There's your hyperbola. Congratulations, you just grabbed your first hyperbola.
Ah.
So glad I could be here for this special moment in your life.
On St. Patty's Day.
On St. Patrick's Day, what more could you want to do?
Ah.
Great.
One that I forgot.
Great.
Cut away.
Okay, for domain and range for these,
Oh
I hate doing this.
it's pretty easy. The domain is literally you could plug in any number you want for x except what?
Oh,
3. So you
That.
can say x such that x just can't be 3. If you want to do x as a set of all real numbers, you can do all that. You don't have to.
No,
Okay,
that's too much work.
I'm okay with you just doing that.
1.
Correct. So the range is everything except where the asymptotes are. That's all it is.
Oh, that's easy.
I told you.
I can do this.
Alright, well, let's do the next
X such that x just can't be 3. You could say x is a part of all real numbers except 3. Whatever. I'm good with this.
X cannot equal 1.
I'm not sure what the text will have. Oh, I forgot to do domain and range on number 2.
Uh-oh.
Okay.
Oh,
Oh no, I have to rescan my notes now.
Oh, we might as well just stop.
Alright, last one. Vertical asymptote
Yep.
is when my denominator equals 0, so it's at x equals -2. Make sure you have x equals in front of that. Go ahead, draw your vertical line through -2. Horizontal asymptote occurs if I have a shift up or down. It looks like I'm shifting down 5. So it's all the way down here at -5. All right, and then we just plot some points around the asymptotes. Well, around the vertical asymptote, I should say. So again, if it helps you to put your vertical one kind of like right in the middle, say I know I can't plug in -2, so pick 3 to the left, -3, -4, -5. You need at least 2, -1, 0, and 1. All right, now, folks, if you're typing these in your calculator, be careful. I would probably do it as, like, I would do it step by step. Do, like, -5 plus 2 first. Figure out what that is. Take -4 divided by that, and then -5.
Yeah.
That make sense? All right, here's what I got for these numbers. -3 2/3. -3, -1, -9, -7, -6 1/3.
Wait, -3 2/3? I got wait.
Six.
Whoa, because you gotta go down more. Got it.
Everybody pick one of those and try it in your calculator. Make sure you know how to type it in.
I got it.
I got those separate. Yep. Okay.
Wait. What? Oh, yeah, never mind.
Okay, then you can go ahead and plot those.
Okay.
I just got it unsimplified.
That doesn't look right. What did I do? -9, -7.
Should look something like that.
Oh, maybe I did that one.
And this did get reflected, so notice how my hyperbolas are kind of like in opposite corners than they were on the last one.
Ooh, crap. I almost crossed the
Hey,
line.
that is not a nice word.
So, yeah, set down Nicholas.
All right, now once you get your
I got it, baby.
points plotted, my friends, you just connect the dots, approach the asymptotes.
I think I know the demon.
All right, domain.
My arrows might
X such a X is not equal to -2.
Good job, buddy.
Oh, I'm so smart.
my arrows might touch the lines a little bit.
Oh, yeah. Nicholas.
Can't touch that asymptote.
What about the arrows?
You better. I thought you were better at this.
So I just make like half of those.
What'd you say?
Do I just make like half an arrow?
What's your problem?
Look at my arrows touch the line.
If you mean the pointy part,
Oh,
who
no.
cares?
That's fine.
Oh, okay.
Can I use the bathroom?
No.
No.
Alright, domain and range.
Okay.
Oreos, disco the asymptotes. Alright, that's it, folks. And tomorrow's work day.
Yay, work day!
It's a life assignment.
Except
Hey,
today.
well,
We should have more work days in here.
You're gonna fail.
Knock it off, Weston.